I ran across another tip today that saved me some time and a headache. That was how to duplicate a mesh along the edge of another mesh, like spikes on armor or stitches on cloth, but keep its placement in case of deformation. In manual methods, you would turn on snapping and then move it to each point, duplicating it again and again and rotating it as you need. However, this is super tedious, and also, it doesn't move along with the mesh. So for this better method, we're going to turn to geometry nodes. Select your mesh that you're going to be detailing, and go to your modifiers, add a modifier, geometry nodes, and make a new geometry nodes. Optionally, you can name it. I name it so it might be easier to find in the modifier stack. And then open up the geometry node editor. Hit Shift A to search for a node and search for mesh to curve and drag that between the two endpoints. This converts all of your edges over to curves. However, we want to specify what edges, so we're going to add a named attribute, then attach attribute to selection, which will make everything disappear. Don't panic, we just need to add a vertex group. Hit Tab, select some edges, and then assign those to your newly created vertex group. Then in the named attribute node, once you start typing in name, you will see that new vertex group added to the list. The selection looks a little strange, and that's just because on the named attribute, you want integer instead of float. Now that we have the right edge selected, we want to convert these over to points with the curve to points node. After that, we add an instance on points node, and this will duplicate your geometry to those points. But first, we have to reference that detailed geometry in the node graph, so that's where the object info node comes in. And attach the geometry out to the instance in. Then use the eyedropper to pick your detail mesh. And you'll see it's duplicated that mesh to all the points around the curve, but where'd the main mesh go? You can try dragging the original geometry input to the output, and then those instances to a secondary node, but that doesn't seem to show up with both. So for this, you're gonna need a join geometry node. And now they're both showing up. Cool. We now need a little bit more control over our instances, as right now they are way too large. So from the object info, we're gonna add a transform geometry and just nest that between. And here you can see we can actually lower the scale of the instances themselves. And so I don't have to go digging into the modifier stack every single time, I attach the scale over to the group input, and that way it's visible from the modifier itself. When playing with the rotation, I realized something very important is missing. The instances are not aligned to the mesh at all. So let's change that. So on the curve to points node, let's pull out from the tangent, and we're going to be searching for align rotation to vector and make sure the input is the vector. Then the output attached to the rotation, and you'll see it has actually modified the instances. However, you want to play around with the settings so that the rotation aligns to the vector that you need, which could vary depending on the orientation of your meshes. Attach object info rotation to the rotation. And now I'm going to attach that transform geometry node's rotation over to the group input. So now I get the modifier control. And you can rename and organize these group sockets for better clarity. So I'm going to rename this to instance scale and then instance rotation. So I know it's actually rotating the instance and not the whole mesh. On the instance scale, I'm going to change the data type over from vector to float, and then that way it scales all axes at the same proportion. I'm also going to add the translate to the input so that way I can get all the finite control that I need for placement. Looking pretty good so far, but I also wanted to add the named attribute to my inputs, and that way if I have multiple different modifiers for different vertex groups, that can be done that way. I'll go in here and I'll just rename it to vertex group and kind of reorganize some things. Now let's take a closer look at the node that does a lot of the heavy lifting, curve to points. It has two different settings, one for length, one for count. Length will give you the distance between points, whereas count will tell you how many points are in that total curve. So under length, if I change the scale of the object and then apply the transforms, you'll see that it adds more points between the distance, whereas if I set it over to counts and change the scale, it will keep the same amount of points, just maintain the scale that was set in the settings. So being that this is a pretty important setting, I wanted to add it to my group input. Move that up to the top. But then I realized that maybe I don't want count for this, I actually want length. So I'll rename the input over to instance distance and change it to float so I can get a little bit more finite. Integers are way too large. So now when I move or scale the main object's geometry, those points will maintain a nice distance between them. So now when I want to add a second edge to apply this geometry to, all I have to do is go over to duplicate this, create a new vertex group. Again, don't forget to assign your vertices to the vertex group. And then in that modifier stack, just change the name to what you want. And this is the reason why it's important to have separate modifiers for different edge groups, because the rotation might not maintain, the scale might flip, something like that. So you want control over each edge loop. Now to see how it holds up against deformations, I'm going to add a lattice, then a lattice modifier to the object. And when I move the points on the lattice, you'll see that the detail geometry does not come with it. And that's really easy fix. You just have to move that lattice higher up in the modifier stack. Same if you're adding like some sort of subdivision modifier or something like that. The one caveat to this approach is that if you change the geometry of the mesh itself, so if you add new edges or split edges, you will have to reassign the vertex groups. Lastly, I wanted to add a little bit of scale variation to the instances, and this can easily be achieved through a random value node. You change this over to float and then attach that to the scale. And you'll see you'll get a little bit of variation. That's all for this one. If there's any additional tips that you found useful, let me know. Until next time, see ya.